So introducing RDDs. This is a core component of Spark which we are going to use across all our courses. So please bear with me. This is an important concept which we should understand very thoroughly. So we need to understand this. Let's dive in a little bit. RDD. So basically this resilient distributed data set extracts all our complexity of trying to manage all the fault tolerance and the distributed nature of what happens to all these objects. You can think of RDD as an encapsulation of around a very large data set. After that, probably you can apply the transformations and the actions too. And all you need to do as a Spark developer is to worry about the functions which transforms those transformations and what specific actions you want to perform on this large data. So basically, this RDD takes away all the complexity which Sparks does for you, and making sure it's fault tolerant and resilient, and making sure that if one node goes down, then still your cluster can recover from that, basically from where it left off, and make sure it's distributed. And it contains all the details about how it splits up your data and forms it all the nodes on the cluster. And fundamentally, this is a data. So at the end of the day, an RDD is just a giant set of data, basically row after row after row of information, and that can just be like lines of raw text, or it could be key value information, which we are going to see later on. So where does the RDD comes from? Well, basically when you create a Spark driver script, you can create what we call as a Spark context object. And when you are writing on a Spark shell, you get something called a Spark context called SC. But when you write a code, you specifically write Spark context, and you basically tell the Spark cluster that, okay, this is the kind of cluster I'm running on, and this is the name of my job. So basically, once you create this Spark context, this creates an RDD for you. Now let's have a look at some of the examples. So in this example, we are taking a hard code a list of integer values 1, 2, 3, 4, and using the parallelize method to create an RDD out of it. Well, this is a very small example, which I mean, if you can hard code a list of integers, so then probably you don't need a big data for it. But this is just for the sake of understanding how an RDD is created using a Spark context. But this is helpful when you're developing a set of test cases, or trying to write when you're developing, you're trying to write a unit test wherein you need a small set of test data. So seems to be helpful. And also this is very common that you can load up the file data from the file system. Could be a local file system, or could be an S3 bucket, or it can be an HDFS location, or any other distributed file system which is more of a real world scenario. So basically in the example, you are using an S3 bucket, an Amazon S3 bucket, or a distributed file system using a Hadoop file system. You can also use Hive. Hive is also one of the component of Hadoop ecosystem. Using Hive, we can store the data in a more structured way. And if you have a Hive database, you can actually construct a Hive context given a Spark context, and then you can use SQL queries on your Hive data, and then it can return an RDD which you can then perform the Spark operations on. And there are a lot of other data sources which you can which you can integrate with Spark and create RDDs from, including JDBC, Cassandra, HBase, Elasticsearch, or a JSON file, CSV file, sequence files, object files, and various other compressed formats. So now once you have an RDD, what do you do with it? So basically there are two different things you can do. Basically one is like transform in RDD, which is basically to apply some function to the data within RDD to create a new RDD, or you can apply an action to it. So okay, so you want something to somehow to do something on this RDD which actually reduces down to the end results which I want to get, which I want to retrieve at the end. Let's talk about that. Like transformations first. So the most common operation you can do with an RDD is the map function, which we will going to look at. So as of now, just stick with the concepts. We will see the later examples. So what map does, basically apply a function to an entire map of RDD. Basically apply a function to an entire map of RDD. Basically apply a function to an entire RDD. So let's say you have an entire set of data in an RDD and you want to extract one field from it to perform some parsing on or somehow multiply the things in it, which is passing a function to a map function, that this is how I want to transform every row of my RDD. So go through your RDD one line at a time and will apply your function to each line to produce a new RDD that has been transformed, and under the hood it will magically distribute it that if necessary, and also deal with fault tolerance and whatnot. Now the flat map is a very similar concept, but the difference lies in that you don't need to have a one-to-one relationship between the rows of your RDD which you with the RDD you start with and the final transformed RDD. But with the flat map, you can look at the individual line and say, I am not going to output that at all to the new RDD I am going to create. Or I might want to output multiple lines for each line of my input RDD. So basically, if you don't have a one-to-one mapping between the initial RDDs which you start with and the final transformed RDD, then flat map is your friend in this case. Well, the rest are pretty self-explanatory. Basically, filter which takes a Boolean function that tells it, okay, I want to take everything out of this RDD and it doesn't fit some criteria. So that's a very good way to trim down an RDD initially and pare it down to the data which you actually need. The sooner you can do that, the better, because the less data you push around, the faster it will perform and more and reliable it would be. Distinct just returns the distinct rows if you have duplicate rows in your RDD that can get rid of them automatically. Sample creates a sample of an RDD, very useful for testing. A lot of time you want to develop your script on your desktop and maybe take a random sample of the data or to the datasets which you can actually run it quickly onto your desktop and can get along with your code quickly. And finally, you can perform the set operations in your RDD like union, intersection, subtraction, and Cartesian. products between any two RDDs and then producing a resulting RDDs from those operations. Now let's have a look at the map transformation. Again, we are taking the hard-coded list, that is 1, 2, 3, and 4. So what we are doing here is we are taking a Spark context object, which is S, and calling a parallelize on it with a list of hard-coded values. And all this will do is we'll create a new RDD called RDD, which is creative, huh? And this RDD contains 4 rows, which is 1, 2, 3, and 4. Now let's see how map works here. So getting here a little bit of functional programming with Scala. So basically we are calling an RDD object and calling a map on top of it. And the parameter we are passing in is actually a function. So the function here is take this x as an input and return the value x times x. So by passing in that function that squares every row in the RDD, we get this squares, which is the RDD which is being transformed. So the squares will contain the rows 1, 4, 9, and 16. So the important concept to grasp here is basic. The function here to map gets applied to every individual row in your RDD and create a new RDD named squares as the result. So we are seeing a couple of different functional programming paradigms. That is, one is the concept of little self-contained function like x arrow and then x cross x, which is being used as a parameter. And also to notice that we are using here vals and not var, which is indeed also a good practice for functional programming. Although map creates a new RDD, but it doesn't modify the original RDD, and it creates a new one which is immutable. So just to reiterate the point, so passing this function as an x and this funny little symbol with arrow symbol, then x times x, syntactically which is something as similar to like this, return x times x, wherein we have a separate function and we name it as square it, input a x integer parameter and returns an integer which is x times x, and we can call rdd.map and we can pass in the defined function square it. So basically this is just one of the very compact way of handling very programming in one line. So it's a compact way of handling very complex programming. Now if you do have a more complicated transformation, then it might make sense to have split it into a different function. But for simpler transformations, this one-liner code should. Now let's talk about the actions which you can perform on the RDDs. So these are some of the very most popular actions which you can perform, but for deep dive you can look into the tutorials, the documents. So basically collect, which basically takes the results of an RDD and sucks it down back to your driver script. So that point you can actually manipulate results within Python, print them out or save them out somewhere, wherever you want. But remember, in Spark, nothing actually happens until you call an action on an RDD. So when you call a collect or any of the other actions, Spark will go out and try to figure out what is the optimal path to actually produce these actions, or I should say the results that I want. And at that point, it will construct a directed acyclic and gets it executed in the most optimal manner it on your cluster or on your desktop, wherever you are doing, and then basically return the results. So all these actions is what trigger to actually something happen in Spark, trigger to actually happen something in Spark. So yeah, just collects all the data in your RDD and passes it back to the driver program. Some of the other examples, say you want to count how many number of records in an RDD. Also count by value. It look up for the unique values in your RDD, one for each row, and give you back a count of how many times each value appears. So remember, an RDD can contain duplicate rows, which is perfectly fine. And if you do, you can use count by value. The count of how many of these each unique row values you have. So the take will just take the first n results of an RDD. So if you want to take a little piece of data for debugging, in those cases it will be a useful thing to do. Say just take first 10 rows of an RDD to make sure the format looks right and get it print out. Top, similar idea, and reduce would be a more common thing to do with RDD. And this actually lets you combine together all the different values associated with the unique keys. And we will go into more depth soon. Imagine you have key value pairs in your RDD and you want to reduce all the values for a given key together. Maybe you want to add all them up, or or you may want to multiply them together, or you want to smush them together. So all these ways, reduce will do it for you. And that can actually be a very powerful thing. So again, I want to repeat the point. Nothing actually happens in an RDD until you call an action on it. That is when your DAG or directed acyclic graph gets constructed and Spark figures out the optimal way produce the results you want, and that's when the things get actually kick off and gets executed on your cluster. So this can be a little bit confusing at times when you are debugging. So basically you might be having a bunch of transformations which you are doing, like maps for example, and you might have a print line in your script to see what's going on at that point. Might not do what you actually expect because that map function didn't actually pass anything to get executed. So nothing actually gets executed until you get a call an action like collect or reduce or count. And with that you got the basics of RDD, and it's gonna syncing along more, and it's gonna syncing along more when you gonna look at more examples.